Good afternoon, students. In this lecture, we'll learn about rule-based classification. So, in rule-based classifiers, a learned model is represented as a set of if-then rules. Now, in this section, we will examine how such rules are used for classification purpose and how we can generate those rules with the help of decision tree, and then how we can write those rules without the use of decision tree directly from the training data. So, this all is covered under rule-based classification. So first of all, how do we write rules for the classification purpose? So these rules are written with the help of if-then uh, rules. Now in if-then, we first write the condition after if, and then after then we write the conclusion. This condition part consists of the attributes and their values, and this conclusion part consists of the output class and its value. Like here is an example of rule and R1. If age is equal to youth, so age is an attribute, youth is the value, student is an attribute, yes is its value, vice computer is the output class, and yes it is value. So the portion of the rule which is written before this then, that means the left portion of the rule is called as the rule antecedent, and the right portion of the rule which is written after then is called as the rule consequent. Now, if more than one attributes are used in the rule, we have used an AND operator. Now, this is the short form of the rule. Here we have, instead of AND, we have used the operator for representing the rule. Now, if the condition in a rule or the rule antecedent holds, that means these two conditions are satisfied, then we say that the rule antecedent is satisfied. If both these conditions hold true, then we say that the rule antecedent is satisfied, and we can say that the rule covers the tuple. So in order to find out the quality of our rule, the rule can be assessed by its coverage and accuracy. So if we are given a tuple from the class label data set D, and the rule covers n number of tuples, and then the total number of tuples is D, then the coverage can be defined as n covers divided by D. And the accuracy of the rule is found out by n correct over D, where n correct is the number of tuples the rule has classified correctly. Now here is an example based on the table data 8.1. So let me first open the table 8.1. So I think table 8.1 is now visible to you. So this question says that the rule is age is equal to youth and student is equal to yes. So here we will find age is equal to youth, student no, age is equal to youth, student no, age is equal to youth, student no, age is equal to youth and student yes. So this 9th tuple and 11th tuple are covered by this rule because they have age, youth and student yes. So the total number of tuples this rule covers is 2. So the coverage is 2 by 14, where 14 is the total number of tuples. Now, in order to find out the accuracy, we'll find out how many tuples it covers are classified correctly. So the tuple 9 has the output class yes, and the tuple 11 has also the output class yes. So all the tuples which it has covered, it has classified them correctly. So the accuracy of this rule is 100%. Now, there may be more than one rules which are satisfied. So, whenever a rule is satisfied, we can say that a rule is triggered. So, if there are more than one rules that are satisfied, then it does not mean that the rule is fired, because the rule which is fired is based on certain criteria, and for that criteria we have a conflict resolution strategy. So this strategy is required when there are more than one rules which satisfy the criteria, and in that case if more than one are triggered, then which rule will be fired, it is dependent upon this conflict resolution strategy. So there are many possible strategies for rule firing conflict resolution. So the first strategy is a size ordering scheme. This scheme assigns the highest priority to the triggering rule that has a toughest requirement. When I say toughest requirement, that means the rule antecedent size, the conditions, number of conditions written on the left of the rule. That means after if we write the number of condition and more the number of condition, we say that the rule is tougher. So the toughest rule is triggered, and that rule is fired. And the other scheme is the rule ordering scheme, and this rule ordering scheme prioritizes the rules beforehand. When we write rules, they are written according to some priority. So that priority is also there are two different methods for defining the priority. The first priority is the class based and the other priority is the rule based. With class based priority, what we do is the classes are sorted in the order of decreasing importance, such as by decreasing order of prevalence. That is, all the rules for the most prevalence class come first. For example, if we are having a COVID test data, then most prevalent class is that the test is negative. So the most prevalent class is negative. So that the rules which are belong to the negative class, they will be ordered first. In the rule which belong to positive class, they will be written afterwards. So we have beforehand written the rules. So according to the rule which is triggered and it is at the top priority, so it will be fired. Another rule ordering method is rule-based ordering. In the rule-based ordering, the rules are organized into a long priority list, and this long priority list consists of the rule measures such as accuracy and coverage or the size. So size means the number of attributes, or we can say the toughest rule. And if I say accuracy and coverage, we have learned about these measures. So whichever rule has the highest accuracy, highest coverage, or the toughest rule, they are written beforehand at the top position, and the other rules are written downwards. Or this priority may be also based on some advice from the domain experts. So the rules which are written at the top, they will be triggered and they will be fired. So in this way, we have different conflict resolution strategies when we have more than one rules which satisfy the given conditions. Now this, how to make those rules, so these rules can be extracted from a decision tree also. So whenever we have a decision tree, then with the help of decision tree, we can make the rules. So how to make those rules with the help of decision tree, we'll shortly learn. Just let me share the screen. So now how the rules are extracted from the decision tree. So here we first of all we have learned how a decision tree is formed. So decision trees classifiers we have used, and they are most popular classifiers because they are very easy to understand and they are also very accurate. So what, in order to extract rules from the decision tree, what we do is we one rule is created for each path of the tree, from the root node to the leaf node. So here you can see one path is from youth to student, the other path is from age to middle aged, and the other path is from senior to excellent, and one other path is from senior to fair. So for each of the path in the tree, we write one rule. And so here you can see the examples of the rules for this particular decision tree. If age is equal to youth and student is equal to no, then Bayes computer is equal to no. If age is equal to youth, student is equal to no, then Bayes computer is no. So we have taken this particular branch and written a rule for this. Then second rule is age is equal to youth and student is equal to yes. So this second branch, age, youth, student, yes, and then the Bayes computer is equal to yes. So we have formed two rules. Similarly, if age is equal to middle aged, in Bayes computer is equal to yes, we have written rule for this third, this second branch. And then once again, similarly, we'll rule age is equal to senior and credit rating is equal to fair, then Bayes computer is equal to no. So this rule is there. And for the other branch, age is equal to senior, credit rating is equal to excellent, then the Bayes computer is equal to yes. So we have written rules for both credit rating is equal to excellent and credit rating is equal to fair. Now, if we have written more than one rules, that means either of the rule will be satisfied, because whenever we draw rules from a tree, then these rules are mutually exclusive and exhaustive. When I say mutually exclusive, that means one tuple will satisfy only one of the rule and not more than one rules. And when I say exhaustive, this means that all the tuples they will be covered under these rules. So here we do not require any conflict resolution strategy when the rules are formed with the help of decision tree. Now, the other method for rule writing or the rule induction or rules based classification is based on the sequential covering algorithm. So let me first increase the size of the screen. So in the rule induction using sequential covering algorithm, the if then rules can be extracted directly from the training data. We do not require any decision tree with the help when we write rules using sequential algorithm, covering algorithm. Now, when what is this algorithm is, as the name shows, that the rules are learned sequentially. That means we write rules one at a time. And while when we use decision tree, we use the divide and conquer method, but when we use sequential covering algorithm, we write rules one at a time and not multiple rules at the same time. Like in the decision tree, the rules are written simultaneously, but in a sequential algorithm, the rules are written one at a time. So this is also called as sequential covering algorithm. So for one class, we write rule at one time, then once the rules for one class are written, then we write rules for another class. So here we can see um, when we write rules for one class and then we write rules for other class, then such rules are having high accuracy also. Now when we say that they have high accuracy, this high accuracy never mean that the rules will be of high coverage. When we say high coverage, that means we have written a rule and how many tuples will be covered by that rule. Because if the high coverage is not there, then that rule is not of much importance to us. So in order to learn the rules, what we do is we first of all write a blank rule. If no antecedent, only then loan decision is equal to accept. So only the consequent part is there and we have not added any condition. Now after that we have different attributes and different value pairs. So we find out if loan, for example, we have here used loan term is equal to short, then loan term is equal to long. So these are different attribute values. Then this is another attribute, income is equal to high, low, medium. Similarly, here this is for income here. Similarly, there may be other attributes. Now, whichever attribute covers the maximum number of records, we will take that attribute and write condition for that. So here we can see if income is equal to high, then loan decision is equal to accept, because for income is equal to high, most of the tuples they have the loan decision is equal to accept. Now similarly we will proceed further for every other branch, and now when we have made a rule for this high, then from this high we will other attributes. When the income is high, what all attributes are there? When income is equal to high, then other attribute is age. When income is equal to high, the other attributes we can consider, the other value of the attribute age is middle age. Then the other value could be income is equal to high and age is equal to senior. So for all other attributes like credit rating, for all the values of the credit rating like fair and other, I don't remember the other credit rating values, but for every attribute value, like here we have attribute value age equal to youth, age is equal to middle ages. So for all attribute values, we will find out the rules, and that rules which maximum satisfies those conditions, then we will add them up. So here credit rating is equal to excellent. When credit rating is equal to excellent, then we see that the loan decision is accepted. So we add this particular condition. So in this way, we just go on adding more and more number of attributes towards the rule. So this is called a sequential covering algorithm. That's all in this lecture. Thank you for watching.